Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video will discuss on course SMS 1034 for the course of Introductory Theory of Probability and Statistics. Okay, so this is the contents of this course for the chapter 1, which is the first one is about experiments, outcome and sample space, a simple and compound event, probability of an event, marginal probability, conditional probability, mutually exclusive event, dependent and independent events, complementary events, intersection of events, multiplication rule, union of events, and the addition rule. So basically, it seems that quite many things that you need to know from the first part. Okay, because this is a basic concept. Okay, let's look at the first part, experiments, outcomes, and sample space. So, an experiment by definition is a process that when you perform, result in one and only one of many observations. These observations are called the outcomes of the experiment, and the collection of all outcomes for an experiment is called a sample space. Okay, and this sample space is usually denoted by S, and the element of the sample space are called a sample point. So basically, you have an experiment, and the outcomes of the result of the experiment we call it as an outcomes, and the normally experiment will have several outcomes, and that's why the collection of all outcomes we call it as a sample space. And the notation of the sample space we use capital S. And the element of the sample space are called as sample points. Okay, I repeat, we have experiment, and from the experiment we have the results. Okay, and the outcomes, the result we call it as an outcome, and the collection of outcome we call it as a sample space. And the notation that we use denoted by S. Okay, capital S, and this element of the sample space we call it a sample point. So here the table here we have several examples for experiments, outcomes, and sample space. Alright, so the first column here experiment, the second column represent outcomes, and the third column represent sample space. Okay, for instance, we flip a coin once. The possible outcome will be each other head, H, and tail, T. So the way you write down the sample space, S, is either H or T. And there are several examples here. Roll the dice once. The possible outcome is 1, 2, 3, 4, 5, and 6. And also there are sample space as 1, 2, 3, 4, 5, and 6. And let's look at another example. When you have you need take a test, the outcome is either you pass or you fail. So the sample space will be S, which is pass or fail. Okay, you can look at this example of experiment outcomes and sample space later on, and maybe you can find other example of experiment outcomes and sample space in real lives. Okay, for this one is the representation of the sample space. How can you present the sample space? There are two ways to represent the sample space. Is either use Venn diagram or use tree diagram. So by definition, Venn diagram is a picture that depicts all the possible outcomes for an experiment, while tree diagram is a diagram that represented by a branch of the tree. Okay, let's look at example 1.1. Draw the Venn and tree diagram for the experiment of tossing a coin twice. Okay, tossing a coin or flip a coin twice. Okay, the solution is when you toss a coin twice, the sample space will be is either the first flip or the first toss is a head, the second one is also head, or the first one is head, the second one is T or tail, or the first one tail, the second one H, or both is T. So you can represent it by using the first one here, Venn diagram, okay, which is S, H, H, HT, TH, and TT. So for the Venn diagram, remember the element inside these Venn diagrams, we call it as a sample point. So here HH, HT, TH, and TT is the sample point. And for the Venn diagram, it's not necessary this triangle, this rectangular. Okay, the shape, it can be circle or any shape as long as it's close boundary. Okay, next is the tree diagram. Okay, the tree diagram, you can see here the first toss or the first flip, the possible outcome is either head or tail. And then we have the second flip or the second toss. Also, the possible outcome is either head or tail. That's why the final outcomes is the multiplication of the first flip and the second flip, or the first toss or second toss, which is you multiply HH, HT, TH, and TT. So this is how we represent sample space. It's either using Venn diagram or by using tree diagram. Okay, another term that you need to know is simple and compound event. Okay, by definition, event is a collection of one or more of the outcomes of an experiment. Okay, event in Malay we call it as peristiwa. So it is a collection of one or more of the outcome of experiment. And then we have term simple event, which is event that include only one and only one of outcomes. And then we have compound event, which is a collection of more than one outcome for an experiment. So by definition, simple event represent only one outcome and compound event represent more than one outcome. Okay, let's look at example 1.2. Suppose we randomly select 2% from the members of a club and observe whether the person selected each time is a man or woman. So there are 4 possible outcomes, which is MM, MW, WM, and WW. So the same concept is applied here, similar to those when you flip a coin twice, but here you want to choose 2%. So it's either first person and then the second person. So the first person is either man or woman, and the second person either man or woman. So MM here represent the first and the second person is man. MW represent the first man, the second woman. WM represent the first woman and the second man. And WW represent both are woman. So the question is, A, list the simple event. And B, if A is the event that at most one man is selected, list the compound event. Okay, so remember, simple event represent only one outcome. So here, from the possible outcome here, MM, MW, WM, and WW, each one of it, the individual outcome itself is the simple event. How about B? If A is the event that at most one man is selected, list the compound event. By definition, at most one is selected. Therefore, it can be at most one man or both are women. And it's not include both men. So here for B, A should be MW, WM, and WW. Okay, so the concept is the same to the one those we did for the flip of coin. So this is how you do it at the solution. So basically each of the final outcome, which is MM, MW, WM, and WW, can be represented as a simple event, and you can use the notation E, capital E, as the notation for each simple event. Okay, so each one of it, E1 MM, E2 MW, E3 WM, and E4 WW. And the second one, this is the one that I said just now. A is the compound event. At most, one man are selected. That means it's either one man are selected or both are women. So obviously, it cannot be both men. That's why compound event A is MW, WM, WW. Okay, next part is about probability of an event. By definition, probability is a numerical measure of a likelihood that a specific event will occur. Okay, probability is a numerical measure of a likelihood that a specific event will occur. If you have event A, so PA represents probability of event A. If you have B as your event, so PB will become probability of event B. Okay, so there are three basic property of probability, and the first two here is the most important, which is the first one for any event A, PA must always greater than or equal to 0. Okay, so here means the individual probability must always greater than or equal to 0. And then the second property, PS equal to 1, means the total probabilities, S stand for sample space, the total probability must always equal to 1. Okay, here we can conclude that probability must between 0 and 1. It can be 0 minimum, it can be 1 maximum. Then probability must between 0 and 1. Okay, so you must remember these two properties. First one, probability of event A must always greater than or equal to 0. And the second one, total must equal to 1. Okay, let's look at example 1.3. Okay, example 1.3, you must back to these properties, number 1 and number 2. Okay, this property is very important for probability, so please memorize it. Okay, probability of an event must always greater than or equal to 0, and the total probability must always equal to 1. Okay, example 1.3, an experiment has 4 possible outcomes A, B, C, D that are mutually exclusive. Explain why the following assignments of probability are not permissible. Why we cannot say that the combination of probability in A and B are not permissible or cannot call as the right probabilities. Okay, first of all, you need to remember the second properties, individual probability must always greater than or equal to 0. So for this case, look at PA, PB, PC, and PD. Individually, you can say that each one of it are greater than 0. So it fulfills the first properties of probability because each one of the probability is greater than 0. How about the total? Okay, maybe you can just take out your calculator. The total PS, or for this case, PS equal to PA plus PB plus PC and PD. So you need to add 0.23, okay, plus 0.46 plus 0.35 plus 0.1. Okay, when you total up, the total PS is equal to 1.14 for question A. So obviously 1.14 is greater than 1. Even though PS should be maximum 1. That's why for question A, the combination of the probability are not permissible because the total probability is greater than 1. Similar for question B, we have PA 2 over 11, PB 6 over 11, PC 3 over 11, and PD 1 over 11. Okay, the first property, obviously you need to check individual property must greater than or equal to 0. And you can see PA 2 over 11, 6 over 11, 3 over 11, and 1 over 11. Each one of it are greater than 0. So it fulfills the first property. Okay, then we check for the second property whether the total is equal to 1. So obviously you can see that PS equal to PA plus PB plus PC plus PD for question B, which is 2 over 11 plus 6 over 11 plus 3 over 11 and plus 1 over 11. If you total up, you got 12 over 11, which is obviously greater than 1. That's why the combination of probability in B is not permissible. Okay, so for this case, you need to remember the most important, those two properties of probability. Okay, next is probability of individual outcomes. Okay, example 1.4, if we flip a coin twice, what is the probability of getting at most one head? So here, in order to answer this, first of all, you need to sketch the tree diagram. Okay, so in order to sketch the tree diagram, maybe I can just show you how to get it so that you get some idea if you have this type of question, how to answer it. Okay, let me just show you using so for this is example 1.4. Okay, sorry for the handwriting. Okay, because when you sketch it using your pad here, you can actually tell where is the location of your writing. So this is example 1.4. Okay, first of all, you need to divide it into two parts. Okay, so in order to find the probability of at most one hit. Okay, so the question is find the probability at most one hit. Okay, at most one hit when you flip a coin twice. Okay, so in order to answer this, first of all, you need to draw your tree diagram. So remember, you flip it twice. So you have the first flip. Maybe you can just divide it into like using this kind of divider or line. And then we have the second flip. And remember, the possible outcome when you flip a coin is either you have H, head, and T, tail. Similar for the second flip, is either you got head or tail. And then, how about the possible outcome? So the possible outcome basically is the multiplication of the outcome from the first flip and the second flip. That's why you got hash hash, hash t, t hash, t t. So you can list out the possible outcome using the sample space notation, using set notation, s equal to hash hash, hash t, t hash, and t t. So how to find the probability at most one hit? So first of all, you need to kind of list out the possible outcome. So the possible outcome for at most one hit exclude two hit, hash hash. That's why it's only equal hash t, t hash, and t t. So your A is basically hash t, t hash, and t t. And then basically how to find the probability, there are two ways. So first of all, maybe you can just find the probability for each one of the possible outcome. And for that, for probability of hash hash is basically 1 over 2 times 1 over 2, which is 1 over 4. Similar to p hash t, p t hash, and p t t. So each one of it is 1 over 4, 1 over 4, 1 over 4. Okay, so therefore, probability of A is basically 3 over 4. Okay, so another way is basically you just find the total number of sample point in A divided by total number of sample number of sample in S. Okay, that's why PA is equal to number of small n, number of sample in A, which is 3, divided by number of sample in S, which is for this case is 4. So basically, then you get 3 over 4. Okay, so this is example how to find probability of event in which you flip a coin twice. Okay, so basically there are two ways. Either you use the NA of NS or you might find the probability individually for hash hash, hash t, t hash, and TT. Okay, let's go back to the slides. So this is the one that I show you just now. Probability of event A is equal to sample size for event A divided by sample size for event S, which is the sample space. PA equal to NA over NS. Next example 1.5. Find the probability of obtaining an even number in one row of a dice. Okay, so when you roll the dice once, the possible outcome will be 6, which is 1, 2, 3, 4, 5, and 6. That's the possible outcome or sample space when you roll the dice once. Okay, for this question, example 1.5, let A be an event that even number is observed. So even number A is equal to 2, 4, and 6. Okay, so by using the probability of an event, NA over NS, so you have A, 2, 4, and 6. What is your NA here? NA is 3, which is 2, 4, and 6. And NS is 6, which is 1, 2, 3, 4, 5, 6. Okay, so you have NA3 and S6. That's why you just divided 3 over 6. So PA is equal to number of outcomes included in A, which is 3. Total number of outcomes, which is 6, 3 over 6, which is equal to 0.5. Alright, so that's the first part of this video, and here is the exercise 1.1. I want you to try to do it, and one of the questions here in exercise 1.1 will become your task. At the end of the video, there will be the list of tasks that you need to answer. So it's cover all those exercise. For the first part here, exercise 1.1, and there will be another two part, exercise 1.2 and exercise 1.3 for this video. Okay, later on you need to try this. Okay, next, the second part of this video is about the counting rule. Okay, if an experiment consists of 3 steps, and if the first step can result in M outcomes, the second step in N outcomes, and the third step in K outcomes, so the total outcomes for the experiment will be M times N times K. Okay, suppose that we need to flip a coin, and experiment is flip a coin 3 times. If you flip a coin 3 times, the first flip, the possible outcome will be is either H or T, which is head or tail, which is 2. And the second flip also, there's 2 possible outcomes, which is head or tail. And the third flip also 2 possible outcomes, which either head or tail. So each flip, there are 2 possible outcomes. That's why the total possible outcomes when you flip a coin 3 times is basically 2 times 2 times 2, which is 8. Okay, so this counting rule really help you to check whether the list of your possible outcomes is correctly complete or not. Okay, for instance, here you know the total outcome is 8, so your list of outcome, which is hash 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 t until t is the correct one, and you can calculate that the total number is 8. 8 possible outcome. Okay, you can see that 2 times 2 times 2 equal to 8. If the first, second, and third, or how many trials, it should be fine as long as you multiply the total possible outcome. Okay, next is about marginal probability. Okay, marginal probability also called simple probability. If you can remember, the first part of the video did represent about simple event and compound event. So if you can remember, simple event is basically referring to only one outcome. So it's related here, simple event, one outcome. So simple probability only represent probability of simple event. Okay, so simple probability related to only simple events. But in this case, simple probability is also known as marginal probability. So when they said about marginal probability, so basically it's referring to simple probability. Okay? Simple probability is related with simple event, which is referring to individual event. Okay, suppose for example 1.7, suppose all 100 employees of a company were asked whether they are in favor or against paying high salaries to CEOs of US company. So the following table shows a two-way classification table of the response of these 100 employees. So for this example, you can see the simple event is in favor, against, male and female. So that is the simple event. So how to find this simple probability or marginal probability? Basically, it's referring to those simple event. For instance, probability of male is equal to 60 over 100. Okay, remember simple event is related to simple probability, and simple event here is male, female, in favor and against. So the simple probability will be, for instance, probability of male 60 over 100. It is use the concept of probability of an event, total number, and male divided by ns, and male is 60 and s is 100. So 60 over 100, and you have p female, p in favor, and p against. Okay, similar, p female is 40 over 100. Okay, next, another term after the marginal probability is conditional probability. By definition, conditional probability is the probability that an event will occur given that another event has already occurred. If A and B are two events, then the conditional probability of A given B is written as PA given B equal to PA intersect with B divided by PB. Okay, PA given B equal to PA intersect with B divided by PB. And most of the time, the denominator PB here is represent the event that already occurred or already happened. Okay, so similar, if you need to find PB given A, so basically it's equal to PB intersect with B, PB intersect with A divided by PA. Okay. So let's look at example 1.8. Compute the conditional probability P in favor given male for the data on 100 employees. So we refer to the same data. So here you need to find P in favor given male. So what is the formula? P in favor given male is basically P in favor intersect with male divided by P male. Okay, so P in favor intersect with male is 15 over 100, and P male is 60 over 100, so it's become 15 over 60, which is 0.25. So that's the solution for example 1.8. So you need to refer to data in example 1.7. Okay, so this is the tree diagram, another way to represent the conditional probability using the tree diagram. Okay, another term is mutually exclusive events. Okay, this is important terms that you need to remember because it affects your calculation of probability. So by definition, mutually exclusive event is event that cannot occur together or event that cannot happen at the same time. Okay, look at example 1.9. Okay, so keep in mind the definition mutually exclusive event is event that cannot happen at the same time. So if I can say the real life example of mutually exclusive event, for instance, event of night and day. Okay, night and day is mutually exclusive event. Why? Because night and day cannot happen at the same time. Okay, you can think of many other example of real life example of mutually exclusive events. Another example may be if you take exam, it's either you fail or pass. Fail and pass mutually exclusive event because those events cannot happen at the same time. When you take exam, it's either you fail or pass. Fail and pass cannot happen at the same time. So there are many others example. Maybe you can just think of it and try to relate with this situation, mutually exclusive events. Okay, example 1.9. If you roll the dice once, so you have possible compound event here. A, when you roll the dice once, the sample space obviously number 1, 2, 3, 4, 5, 6, which is 6 possible outcome when you roll the dice once. And you have compound event A, 2, 4, 6, and compound event B, 1, 3, 5, and we have compound event C, number less than 5, which is 1, 2, 3, 4. So the question is, are events A and B mutually exclusive? Are events A and C mutually exclusive? So you need to check whether A and B mutually exclusive, then check whether A and C mutually exclusive. So remember the definition. Mutually exclusive event is event that cannot happen at the same time. Okay? Events that cannot happen or cannot occur at the same times or cannot occur together. So to check whether events A and B mutually exclusive, look at the possible outcome of event A and look at the possible outcome of event B. Okay, possible outcome of event A is 2, 4, and 6. And possible outcome of event B is 1, 3, 5. So obviously, we can see that there is no number that appear in both events. Okay, 2, 4, 6, 1, 3, 5. So there is no event or number occur in both A and B at the same time. So we may conclude that event A and B are mutually exclusive event. Okay, how about events A and C? So look at event A with 2, 4, 6 and event C 1, 2, 3, 4. So obviously here we can see that number 2 and number 4 appear twice, means it appear in A and it also appear in C. That's why we can say that event A and C are non-mutually exclusive events. So next I will show you how to present this using Venn diagram. Okay, so this is the representation of the answer using Venn diagram. So this is the solution. As you can see, there are two Venn diagram here. At the left hand side here, there is kind of a Venn diagram for the case A and B. As you can see here, there is no intersection between event A and B, event B 1, 3, 5, event A 2, 4, 6. There is no intersection between these two events. So that's why we can say that event A and B are mutually exclusive event. And the right hand side here is the event of A and C, and we can see clearly that there is an intersection between event A and C, which is number 2 and 4 appear both in event A and event C. That's why we can conclude that event A and C are mutually non-exclusive event or non-mutually exclusive event. Okay, next, another term is independent versus dependent event. So there is quite some terms that you need to know before we go to the next chapter. So the first chapter basically more on all the basic terms in probability and statistics which you need to know. Okay, so this is another term, independent and dependent events. So in order to check whether two events are dependent or not, so basically if you have two events A and B, so to check whether two events are independent or not, so the formula will be you need to find PA given B. If you have two events A and B, first of all, you need to find the left hand side here PA given B, and then you find the right hand side PA. Okay, and then you compare between these two. If it is equal, then you can say that these events are independent events. If it is not equal, then we can say that A and B are dependent events. So the keyword here to find independent or dependent, you need to find or calculate the left hand side and right hand side, and then you compare. If it is equal, then it is independent. If it is not equal, then this is dependent. Okay, so to check A and B independent or not, is either PA given B equal to A or PB given A equal to PB. Okay, let's look at example 1.10. So refer the information on 100 employees from preceding example. Evans female F and in favor A independent. So you need to kind of refer to example, previous example about the 100 employees. Maybe you can check which example is it. Is it? I think 1.7. Example 1.7 maybe. Let me check. Yeah, example 1.7 about the 100 employees. So we use the same example to answer example 110. Okay, so here they want you to check whether even female and in favor are independent. So remember here to check whether F and A are independent or not, you need to find F, probability of F, and you need to compare probability of F given A, or you need to find probability of A and you need to compare probability of A equal whether it's equal to PA given F. Either one. Okay. So for this question, you need to find PF first. So from the table of 100 employees, example 1.7, you can see that probability of F is 40 over 100, which is equal to 0.4. And then you need to compare with the right hand side, PF given A. PF given A is basically PF intersect with A divided by PA. So you got 4 over 19, 0.2105. So obviously here you can see that PF 0.4 is not exactly equal to PF equal to A, or not equal to PF equal to A, which is 0.2105. So obviously here, if it is not equal, then we can make a conclusion that even F and A are dependent events. Okay, so even A and B, even A and F are dependent events because it is not equal. So you may also check PA equal to PA given F. Okay, it will give exactly the same conclusion. Okay, next is complementary events. Okay, the complement of event A, normally denoted by A bar, there is a line on the top of A, we call it as A bar, and sometimes they use A prime, which is represent A complement, and some book may use A C to present complement of A. Alright, so by definition, probability of A plus probability of complement A is equal to 1. So that's why it's always right that PA is equal to 1 minus probability of complement A. And with this, if we represent it in a Venn diagram, so if this is event A, so other than A, which is complement A. Okay, that is how we represent complements events. Okay, let's look at example 111. In a group of 2,000 taxpayers, 400 have been audited by the IRS at least once. If one taxpayer is randomly selected from this group, what are the two complementary events for this experiment and what are their probabilities? So you can see here for this question, there are two questions here. What are the complementary events? And the second one, what are the probability? Okay, first of all, you need to identify out of 2,000 taxpayers, 400 have been audited. So obviously, your event A here is has been audited, and your complement A here is taxpayer that never been audited. So you have A and complement A here. And the second one, after you list out those event, so you need to find the probability. So obviously from the question, in order to find PA, which is taxpayer has been audited, is actually 400 over 2,000. So 400 over 2,000, you got 0.2. Okay, so by definition, as we know, PA plus P complement A is equal to 1. So PA 400 over 2000, and P complement A is 1600 over 2000. Or in other words, you can use the formula PA plus P complement A equal to 1, in which P complement A is equal to 1 minus 0.2. That's why you can get 0.8. So here there are two ways to find P complement A. Okay, so the total is equal to 1. Alright, so that is the second part of this video. So this is the exercise. There are several questions in exercise 1.2. So I believe you can just try to do it later on. Okay, and some of the question here will become your task question at the end of the video. So maybe you can just look at it later on. And obviously all the notes have been uploaded in my Guru. So you may look at it all the slide. Okay. Okay, come to the third part of this video. We have here intersection of events and the multiplication rule. And at the end of the video, we have another subtopic related to union of events and the addition rule. So for this first part, intersection of events and the multiplication rule. Okay, the intersection of A and B represent the collection of all outcomes. They are common to both A and B, and the notation for the intersection, several notation can be used. Okay, for instance, A and B, A intersect with B. Okay, and then AB. So there are several ways to represent intersection of events, and it depends on which book that you use. For this part, intersection of event, most of the time we use N. Okay, A and B. And at the bottom there is the Venn diagram, and as I said just now, if there is an intersection between event A and B, we write down there as A and B, which is the intersection of those two, event A and B. So this is the Venn diagram. And then we have the multiplication rule. Okay, the probability that event A and B happen together is called the joint probability of A and B, and is written as P, A, and B. Okay, as I said previously, the notation of intersection is A and B. A intersect with B, or PAB, or AB, sorry. Okay, so the joint probability will be PA and B, PA intersect with B, or PAB. And the multiplication rule, so you need to kind of memorize this. PA and B is equal to PA times PB given A. Okay, PA and B is equal to PA times PB given A. Okay, this one you need to kind of memorize it. Look at example 1.12. The following tables give the classification of all employees of a company by gender and college degree. Okay, this is contingency table. We have male, female, college graduate, G, not a college graduate, N. If one of these employees is selected at random for membership on the employee management committee, what is the probability that this employee is a female and a college graduate? So this is the keyword here. Female and, okay, and here is the keyword. Female and a college graduate. So you need to find P, female and college graduate. So this is the solution. So basically you want to find P, female and college graduate, which is P, F and G. So by using the multiplication rule, P, F and G is equal to PF times PG given F. First of all, you need to find PF. For this question, you just find PF, which is 13 over 40. And then G given F, you got 4 over 13. You substitute these two figures in the multiplication rule equation, and you got 0.10. So what is the conclusion? Just the probability is 0.1 that F and A just now. Okay. How about the multiplication rule for independent events? So remember previously A and B are independent. A if and only if PA is equal to PB given, PA equal to PA given B. So for this case, multiplication rule PA and B equal to PA times PB. Why? Because PB is equal to PB given A. Okay, so the actual multiplication rule should be PA and B times PA times PB given A. However, because A and B are independent, PB given A becomes PB. Okay, you need to check again the notes on independent versus dependent events. Okay, let's look at example 1 to 10. An office building has two fire detectors and the probability is 0.02 that any fire detector of this type will fail to go off during a fire. Find the probability that both of these fire detectors will fail to go off in case of fire. First of all, maybe you can let the first fire detector is A, the second fire detector as B. Okay, so fire detector, there are many forms of fire detectors. Most of the time is the smoke detector. Okay, so in order to find probability of both, probability of both means probability of A and B. So probability of A, obviously we know 0.02, and probability of B. For this case, we never know it, but we know the nature of the fire detector, they are independent. If the first fire detector in room A and the second fire detector in room B, they are independent. Only room with where the smoke or the fire happen will detect the fire, and for example the bell will ringing, so it will not affect the room which actually don't have the fire. So the nature of the fire detector is independent for this case. That's why PB, the second fire detector, is independent from the first fire detector A. That's why we have PB as well 0.02 and also 0.02, and you have PA and B is equal to 0.02 times 0.02, which is 0.0004. Okay, so here we use multiplication rule but with the independent event. Okay, next is joint probability of mutually exclusive events. So remember the concept of mutually exclusive events is an event that can happen at the same time, or it is impossible for the mutually exclusive event to happen at the same time. So here is the joint probability of mutually exclusive event. If you have event A and B and you want to find the probability of A and B, and you know A and B are mutually exclusive, so basically the probability of A and B will be equal to 0. So remember the example, the real life example that I gave you previously at the early stage of the video, in which, for instance, night and day. Okay, night and day is two events that are mutually exclusive. So the probability that night and day will happen at the same time is impossible, which is equal to 0. Okay, so let's look at example 415. Another example for loan approval. Okay, if you have A as loan approved, R as loan rejected, so what is the probability that loan will be approved and rejected at the same time? So obviously it's impossible. When you say the probability is impossible, mean the probability is equal to 0. So for example, for 15, probability of a loan to be approved and rejected at the same time is impossible, which is equal to 0, because A and B are mutually exclusive event. Okay, next is union of events and the addition rule. So the notation of union of events is A or B, or A union B. So the keyword here or. Okay, previously for the intersection the keyword is and. So at the bottom here is the Venn diagrams. Union of A and B basically include all in A and in B. So this is the addition rule. Okay, addition rule, remember the keyword is or. So basically the addition rule, if you have two event A and B, so PA or B is equal to PA plus PB minus PA and B. Okay, PA or B is equal to PA plus PB minus PA and B. So let's look at the example for 16. So university president has proposed that all students must take a course in ethics as a requirement for graduation. 300 faculty members and students from this university were asked about their opinion on this issue, and the table below give a two-way classification of the response of the faculty members and students. Okay, look at this example for 16 and how to apply it using addition rule. So faculty member here represent academician of the lecturer. So for this we have faculty, student, favor, oppose or neutral. So the question is, find the probability that one person selected at random from this 300 person is a faculty member or, so take note this keyword, faculty member or is in favor of this proposal. So you need to find probability of faculty or favor. Okay, probability of faculty or favor. Okay, look at the data, and in order to find probability of faculty or favor is basically probability of faculty plus probability of favor minus probability of faculty and favor. Okay, that is how you kind of represent the example for 16 in addition rule. Probability of faculty plus probability of favor minus probability of faculty and favor. Okay, let's look at the solution. Let A be the faculty member, B be a favor. So probability of A or probability of faculty is 70 over 300, and probability of favor is 135 over 300, and probability of A and B is equal to 0.15. Okay, so basically you substitute all this: PA 0.2333, PB 0.4500, and PA and B 0.1500. Plug in all this value into the addition rule, and you got the answer 0.5333. So therefore, the probability that if one person are randomly selected from these 300% in which the faculty or favor of this proposal is 0.53333, which is approximately 53%. Yeah, of those 300% is favor or faculty. Okay, so you may look at this example again later on, because basically that's it for the third part of this video. So here is exercises 1.3. There are several questions here, so obviously you need to kind of do it later on, and some of the question is in this exercise will become your task question. Okay. Okay, as I said just now, at the end of each video, there will be a task for you to do it. So basically, what is the purpose of this task is basically to make sure, just for me to check or to make sure that each one of you actually participate in all of the tasks, and just to make sure that I know that all of you look at the video as our lecture material, so that based on the task, I know whether you can do it or not. So basically, how for me to check whether you understand this video. So basically, by doing this task. Okay. So this task as well been measured as your attendance. Okay. So to those who do the task, I will assume that you actually attend and you look at through the video that been uploaded. Okay. So how to make sure you attend this, how to answer or how to submit whether you attend or do the task. So basically, you just need to write down your name, metric number, and group, which is group C, and give me the link of the solution. Okay, give me the link of the solution. So basically for the task, exercises 1.1 number 3, exercise 1.2 number 4, exercises 1.3 number 3. So you need to do all this and save it as PDF and give me the link. So I repeat, give me your name, metric number, group C, and give me the link. Okay, so I think that is all for this one. Feel free to discuss further in our WhatsApp group, and please treat the group as our lecture. Okay, I think that's all for today and for this first video. Thank you and all the best. Assalamualaikum.